Hello everyone, I am Sneha, co-founder of Web3 Compass, and welcome to another episode of Build with Stylus Rust Edition, a hands-on video series designed to help you write smart contracts in familiar languages like C, C++, Go, and Rust using Arbitrum Stylus. And in this episode, we are going to build a complete ERC20 application using Rust and Arbitrum Stylus SDK along with a very cute little React front end. This entire hands-on session will take you from the setup to deployment, covering the entire development cycle of a candy minting token DApp. And this series is brought to you by Namaste Arbitrum, which is a young growing initiative to build the Arbitrum ecosystem in India through content, education, and real-world projects with Web3 Compass as technical partners. About Web3 Compass, we are a platform by builders for builders to help you learn all things Web3 and AI through carefully curated campaigns. This entire workshop is structured to guide you through setting up your development environment, creating a Rust-based ERC20 contract, deploying a contract through Arbitrum Sepolia testnet, building a React front end to interact with the token, and just test the complete DApp. Okay. And we've done a lot around the development section, like setting up the development in our previous series where we built something called a My Counter DApp and we installed cargo and we made sure that all of your development setup is up to date. So yeah. This is something that we're going to build. It's a candy token dashboard in which we are creating a candy token. Now you guys can create whatever you feel like. If you want to create a token based on the name of your pet, on your favorite movie, favorite avatar, whatsoever. And it's going to have two major functions. One is mint tokens and one is transfer tokens. So mint is basically creating your tokens and how much you want to mint, and then transfer would be sending from one wallet to another. And yeah, that's pretty much it. I'll take you through the project structure, but a heads up, we are going to use a lot of AI stuff here because come on, AI is the new trend. So you got to learn to build fast while you also understand how everything sort of comes together when you're building with AI and something maybe that you're not fully aware of. For example, Rust in this case. I did a lot of experiment for coming up with this entire thing. So your entire project structure is going to be like this. There would be a contracts folder, which will have a source folder, which will have lib.rs. Again, all the Rust files have .rs extension, lib.rs, ERC20.rs, and main.rs. And ERC20.rs is basically your ERC20 contract implementation. And lib.rs would be the main contract entry point. And main.rs is basically a binary target for deployment. And yeah, you will understand a lot of dependencies and other thing in Rust and how to put everything together. There would be a dependency file called cargo.toml. Then you will have a JSON file, which is a generated ABI. ABI stands for Application Binary Interface, and that is how you're going to interact with your smart contract and your front-end application. And then another folder inside your token DApp would be a React front-end. So you will have the main application component, you will have configuration, contract configuration, and network, and then multiple components. You can definitely experiment with the front end part and create as many, have a different theme or whatsoever. And yeah, that's pretty much it. So we'll get to building, but just a heads up, whatever tool that you're using, Cursor, Windsurfer, any AI tool, make sure that you ask the tool to constantly update what it has been working through so that you have enough context of the progress of the project, as well as you can take some time and understand what it is doing, because no matter how fast you build, there's a lot of debugging that's going to happen. It's not the same how you do it when you know what language you're building in, or that rush of you building just the next billion-dollar project, but there's going to be a lot of learning involved. So let's just get to building. I am assuming that all of you have set up your dev environment because we showed that to you in detail in the last video. We don't need the Nitro dev node here, but you know how to run a local Arbitrum chain for testing. You have Cargo Stylus installed because that's what we're going to use heavily for building, checking, and deploying. And yep, let's just get to building, guys. So now, before we, do everything, we know that we need to set up the development environment. So I'll just give you a quick recap. Make sure that you have Rust and Cargo installed. Again, I'm not going to do the installation because this is going to take forever, but we have given you the entire resource around it. Make sure that you've added your WebAssembly target. You have node.js installed, depending on what OS you're using. And you verify all the installations, okay? I know you've installed it, but it's very, very important to sort of verify it. So Rust, Cargo, Node, NPM, all of it, okay? Now, the Rust and Cargos are again very essential for building our smart contracts. That's the entire layout. The WebAssembly target will allow you to compile the Rust code to WASM. That's the entire idea behind Stylus. And Node.js and NPM are basically needed for our React frontend. So you got to have all of this. Now, any one of you remembers how did we set up the project structure last time? Come on. Very basic. You create a new directory and then you just, go to that current directory. So you will use probably a mkdir command and then just go to the current directory. Now inside this directory, you'll have to create two subdirectories. Like I showed you, that there would be a contracts segment here and then there would be a React front-end segment here. Okay, so one is your front end, one is your contract implementation, which is basically your back end, and then you just go about like building. Okay, so once you have created these directories, the first task that we're going to do is implement the ERC20 token contract. Okay, now we are going to set up the cargo.toml file because that is where all of our dependencies are going to be. So you just migrate yourself to CD contracts and then come to, let me just close this, and you come to the cargo.toml file. So if you see, all of your packages, dependencies, dev dependencies, features, bin file, lib, profile.release, all of it is here. Okay. Now, some of the times you don't really understand and it's okay. You just have to understand it enough for you to be able to debug. For example, there might be a case that certain versions of Rust or Cargo that you have is downgraded and you need some other dependencies here. Now, don't worry, you don't have to figure out these dependencies on your own. There is an entire repo of ERC20 implementation in Arbitrum Stylus. Again, it has some dependencies issues, but now you have this upgraded GitHub repo as well. So you can just take a look at it and you just need to understand that, hey, these are the dev dependencies. If you come across errors around versions and everything, you just have to upgrade or downgrade the particular thing. Okay. Now, this is like pretty much it, but let's just go to the contracts. Oh, we were already in contracts. Let's just go to ERC20.rs, right? Now, this is basically the main implementation. For everyone who doesn't know what ERC20 is, it stands for Ethereum Request for Comment, and it's a standard to create fungible tokens on Ethereum network. So before you try to understand how it is implemented in Rust, make sure that you've gone through the Solidity implementation of ERC20. And it's more like, think of it like this. If you want to create a token, okay, you would want to think of a name, you would want to think of a symbol, and then you would want to think, okay, how many tokens do I want to create, right? So it's more like name, symbol, and then supply around it, right? And then what functions would you want to implement? Like, now again, you're not free to choose, but it's a limitation. For example, you would want to mint those tokens. That's how you're going to create it. If there's a limited supply or if there are conditions, you would also want to maybe destroy those tokens after certain use. Maybe if someone has sold it and you want to sort of limit the circulation thing, and then you should be able to send those tokens. So there would be a transfer section and all of that. So these are the main functions that are anyway implemented in Solidity. There's a more optimized version of it where you import the entire thing using OpenZeppelin's framework, and all you have to do is just give your name and symbol and you just mint the entire thing. But I would really recommend you to take a look at the entire implementation of the ERC20 token in Solidity, and then come and look at, how the entire Rust thing is working. Okay. So now we're going to do a few imports again. Also, disclaimer that this code is not audited and not fit for production use. So if you're building some production level dApp, be very careful. If you're creating some fun projects like me, just go about it. Okay. So now we're going to do a few imports. This is a very common way. This is how most of the programming languages would show imports. The entire code starts with imports. Okay. And then you would see that, okay, there's a ERC20 parameter trait that is being created, and then they're declaring it as like the three parameters that we've been talking about: name, symbol, and decimals. And you will see how we're going to sort of initialize the values, later. Now, you will define an ERC20 storage, which is basically going to implement all the ERC20 methods. And this is how you do it. And then there's a struct created. There's mapping around it. Now, again, you should have some background in Solidity here to understand how this mapping and everything is working. Now, mapping is basically the key value pair, which we anyway study in data structures. And we're trying to map user to balances. So there's an address, there's uint 256, which is again the balance of the person in the whosoever the wallet belongs to. And then again, another function that we're going to use is transferFrom or allowance segment, where I would want someone to have a limitation on about how much money they can spend. Maybe if I give my younger sibling the access to my account, I would say, hey, you can spend as much as 5,000 rupees, but if there's anything more that you want to spend from it, you have to ask for my permission. So that is what we're doing here, that we'll keep mapping of each of the spenders allowance. Then we're going to talk about the total supply and how are we letting it allow ERC20 parameters here. Now, this is how we're going to declare events in Solidity and error types in Solidity. So there are two events that we're talking about: transfer and approval. Again, transfer function from, to, and how much, right? Now this transfer is how all the transfers work, be it a UPI to bank, to wallet, whatsoever, that there is a person sending the asset, there's a person receiving the asset, and there has to be a value of the asset, right? And then now here we are talking about approval. The example that I gave, if I am the owner, my youngest sibling is the spender, so how much am I allowing him or her to sort of spend? And then we'll have to take into consideration the errors that we might come across, which is, what if there's insufficient balance? What if my sister is trying to spend more than 5,000 rupees and I have put up a contract for it that, hey, this is not what you're allowed for, so it's insufficient allowance. Now, again, what we're doing is also sort of declaring ERC20 error here with the help of enums. I can't get into all of the explanation of, enums and structs, so you might have to do a lot of search here, but I really hope that you take that much of interest. Okay. So this file is basically going to define everything: storage structure for ERC20 parameters, events that will be emitted, custom error types, and all of that. Now we come down to implementing the ERC20 methods in the same file. So methods that are marked as pub here are all usable outside of the ERC20 module, and pub is basically public, and they're all callable from the lib.rs file. Okay. So here, we're trying to implement a function called transfer, as well as also we look into transferFrom. So again, for transfer, you need to specify certain parameters, which is address, like from address to address, value and everything. And then some checks are performed. You'll have to deduct from the sender balance, add it to the receiver balance, and let the contract know that, hey, we have executed this particular function, so you have to emit a transfer event. Now again, you look at the Solidity code, you understand it. We are trying to perform a function. It's like, just understand it in simpler ways. If you're doing a UPI transaction, right? Every time you send the money, it's not like you are sending it to someone and then you just put in your UPI pin and boom. No, there are a series of events that happens after that. It will show a check mark with some fancy sound that, okay, this is transferred or this is pending, this did not go through. Then your balance gets deducted, the other person balance get increased and all of that. And that's exactly what's happening here. So it's no rocket science. It's just basic understanding. And just the syntax might be an issue here. Rust becomes an overwhelming language for a lot of people, but then if you keep calm and just learn and build, you'll get through it. So that was a pep talk. Now, you also need to implement the main function. Again, it's public. So we'll be calling all of these functions from lib.rs file. Yeah. So we are minting the token. Now if you are creating the tokens, then it's basically transferring it to self, and then you are creating a certain number of tokens, right? So that is why it says mutable, self, address and value, right? And then you'll have to increase the balance. You will increase the total supply and you would emit the transfer event. Now, always remember, when you are creating tokens, there is something called as zero address, because you are the creator. There is no one transferring it to you. And that is why the from address would be a zero address, like basically non-existent, and there would only be a to address, and then there will be value. Okay. So I hope that's easy to understand. Now again, there's burn function, which is more like destroying the tokens. Not very relevant. We are not implementing it like on our front end, so it's fine. And now we will look into how are we going to implement the entire, parameter, angles and all of that. So here there is a public function name. Again, it takes the name, symbol and decimals. These are the three parameters that we declared upstairs at the start of the file. So there would be also total supply. There would also be balance of. Now here they've implemented the transfer function as well. What else? They've also implemented transferFrom. So from to value, and if there's an allowance here. So transferFrom, two different things. Okay. How you understand it is more like transfer is just you transferring from one account to another, and transferFrom would be transferring from maybe someone else's account to someone else's account. You just have the spender's allowance. That's it. So that is why it says transferFrom, because one account, you have to transfer from one account to another, but it is not your account. If it would have been your account, then we're talking about just normal transfer, functions. Okay. So you will see a lot of these. Okay. You will see balance of, transferred, approved, transferFrom, and yeah, everything that how once you read it, and it's just try to understand what it would mean in general English language. And that's what exactly is implemented in the code as well, right? Now, we've talked about mint, burn, all of that. Okay. Now what we'll do is, this is the approve function. So it approves the expenditure of value tokens of message sender to spender. Again, very simple. Returns the allowance of spender on owner's token. So that's more like the entire ERC20 implementation. But what is important here is the lib.rs file, because this is the contract that will use our ERC20 implementation, and you will call a lot of ERC20 functions from here. So it says modules and imports. So what it is importing is the module ERC20. And again, it's doing a few imports here. Now you will see that the struct and the parameters that we were taking there, you are defining the names of it, right? So there, like in this particular file, it was just, it was just a declaration. But here you're actually adding values. So for me, the token is called candy token and the symbol is candy. But if you want to maybe create a token on your pet's name, this is the place where you're going to make the change. Okay. So it could be, oh, now I cannot remember any pet's name. Okay, Bruno. Yeah, Bruno is a dog. So Bruno token, and then the symbol could be Bruno here, Tuffy, Rocky, whatever it is, right? And I also mentioned that in Ethereum, the set decimal standard is 18, and that is why we declare the decimal as 18 here. Now, we'll define the entry point of the Solidity storage object. The macro declaration was declared here in ERC20. So you will see a lot of relevance, one after another, how each of the thing comes into play. Okay, so we are doing soul storage here. So here we're going to do, okay, this is the entry point, and struct candy token again allows ERC20 to access candy token storage and make all the calls. Okay. Now, again, we were doing a lot of implementation, and here we are like, once you've defined all the parameters and all of that, we'll just go about implementing, and this is how the implementation is done. Again, same functions, mint to, if you want to mint to another address, if you want to burn, and that's pretty much it. That's all you need. Like, you can go about implementing a lot, like total supply, balance of transfer and all of that, but you don't like really need it. So it's okay. Right now, yeah. What else? Yeah. So basically, even once you sort of try deploying the file, you will see that in the .toml file, there's a bin section and it routes to main.rs. And that is why we'll have to have a file, and it just needs, like, you will see certain errors around that, we need a main or whatsoever, so you can have function. If you change it to lib.rs, it could be your deployment direct file, but it was not working for me. So then I just went about creating a main.rs, and that is why it says that it is intentionally empty, and as the actual contract code is in lib.rs, and this is just going to act as a entry point for deployment. So yeah. Now what we will do is we will build the contract now. Okay, so we will go to mint token dApp, and we will go to CD contracts. Okay. And what we will do is, because we've built the entire thing, last time we wanted to first also check. So we will do a cargo stylus check to make sure that all of our installation is on point. That's it for this episode of Build with Stylus. Keep learning, keep building, and follow Namaste Arbitrum and Web3 Compass on Twitter, YouTube, everywhere, and you'll see a lot about us in the coming future.